We'll proceed in tedious calculus problems. Okay, so we are solving tedious calculus problem, and probably we will expedite, means we will make the speed up if we take other examples. But first example, we are kind of dumping all the fundamentals that we are pursuing as far as calculation of calculus is concerned. And we have come to a conclusion that calculus works in two phases, two ways. There are two branches of calculus, and one is integral calculus and other is differential calculus. Integral calculus is analogous to multiplication and differential calculus is analogous to division. Difference between multiplication, division and integral and differential calculus is here, here it is only algebra. In calculus, there is only algebra, and one is independent component and one is dependent component. If it is differentiation, then denominator is independent component and numerator is dependent component. And if it is multiplication, integral calculus, then integrand is dependent component and differential part, that is the independent component. And in that fashion, if we have density of a, if we have density, there is something called density. If I have a density of a material, then I can calculate the weight of the material by multiplying it with the volume. If density is constant, 1, 2, 3, 4, 5, 6, then directly I can multiply with the volume. If density is 4, and then I want to 4 kg per meter cube, and I want to calculate the weight of a sphere, then 4 into 4 by 3 pi r cube, that is the net weight of the sphere. But if density itself is algebraic equation, then we have to apply integral calculus. Density into volume is the net weight, that is true. But when density is dependent upon volume, then this multiplication comes in a kind of a, it becomes a kind of a case of integral calculus. If density is function of a volume, if I have a sphere and a sphere is centered at the origin, if there is a sphere, okay, if there is a sphere, there is a sphere and a sphere is centered at the origin, and now every point of the sphere there is different density. Now we have density function at x square plus y square plus z square plus 3. This is called density function. If you watch clearly, then when at origin, when x, y, z is 0, 0, 0, at that point the density is 3. Whereas when x, y, z is non-zero, then it depends upon what the x, y, z is. Far away, far we go from the origin, density is growing. In that sense, what would be the weight of the mass? What would be the weight of the shape? Okay, when density is non-linear, density is not constant, what we see is density is dependent upon volume parameter. What is the volume parameter? The volume parameter is x, y, z. At different x, y, z, density is different. So density is function over volume. F, small f, braces V, bracket close. Function over volume is the density. Function over volume into d of volume. This is the net weight that we see. Any dimensional calculus, we can start with two dimension only. Okay, two dimension means independent component is x axis, dependent component is y axis. Now independent component we can keep breaking as we go along. Anyway, now the density of this sphere is dependent upon volume, that is x square plus y square plus z square plus 3. D of volume, volume is x, y, z. Volume in Cartesian coordinate is x into y into z, or d of x, y, z. That is the volume. Anyway, we started a discussion. We have seen d of x, y, z, that at the end it comes at dx, dy, dz. And limit, integration limit is v1 to v2. As in 2D, we have x-axis and y-axis. If we do integration x1 to x2. Similarly, v1 to v2. Then we broke into z first, then z will be minus square root of a square minus x square minus y square. That is for the sphere. 2 square root of a square minus x square minus y square. And then xy1 to xy2. That is xy plane 1 to xy plane 2. If I dissociate it further, it becomes y equal to minus square root of a square minus x square to y equal to square root of a square minus x square. And then x is minus a to a. This is the full-fledged integration, and we saw that it is extremely difficult. If someone is able to do it, then I would wish all the best. Means he is really genius in integration. Otherwise, we started thinking about a spherical coordinate system, and d of v in Cartesian coordinate system it is dx, dy, dz. Whereas in a spherical coordinate system it is r squared sine phi dr d phi d theta, and this x square plus y square plus z square becomes x is r sine phi cos theta, y is r sine phi sine theta, z is r cos phi. X square plus y square plus z square will come as r square plus 3 bracket close r, r okay, yeah, r square plus 3 bracket close, and then r square sine phi dr d phi d theta. Now it is pretty simple. R is 0 to a, phi is 0 to pi, and theta is 0 to 2 pi. Then we saw it is possible. But question arises is, can't we do in Cartesian coordinate system through the method of substitution? In method of substitution, d of volume, that is d of x y z cube. One is d of x, means d of x axis, d of xy plane, d of xyz cube. Xyz cube itself is a single independent component. If we do so, then we can represent d of xyz cube as d of xyz cube divided by d of r phi theta cube into d of r phi theta cube. D of xyz cube can be written as d of xyz cube into d of r theta phi cube by d of r theta phi cube. Simple multiplication. Now it will become d of xyz cube by d of r theta phi cube into d of r theta phi cube. Since r theta phi are orthogonal to each other, means they are independent component, we can numerator we can write as dr d theta d phi. But what about dxyz cube by dr theta phi cube? Now we did in the two dimension. In two dimension, if we are trying to find d of xy plane by d of r theta plane, then we went how we calculate this. This is somehow called Jacobian also. But anyway, there is no theorem, nothing in mathematics. If you go by step and understand the basics, then you can write. We wrote our own, but later we came to know that it is already invented and it is called Jacobian. D of xyz cube by d of theta phi r. What is d of xy plane by d theta r plane? That we have already talked about. Okay, I'll reiterate, then I believe it will be easy. Now there are two planes. One is xy plane or xy axis, one is theta r. This axis is theta and this axis is r. Similarly here, this axis is x axis, this is y axis. How x and theta are related? X equal to r cos theta, y equal to r sin theta. This is method of substitution we are using. Then what will be d of xy plane? If it is simple dx, and x equal to a is constant. Here r is variable, what we have taken. If we have two independent variables, that is xy plane, then xy plane, there x and y are there, then corresponding method of substitution will come as two independent variables. So x equal to r cos theta, r is variable, theta is variable, y equal to r sin theta. If it is only x, then x equal to a cos theta, where a is constant and theta is variable. Dx equal to a minus sin theta d theta. Or if it is x equal to a cos theta, if we have dx, the dx is same as dx by d theta into d theta. Dx by d theta is a minus sin theta and then d theta. Okay, so for single dimension we can calculate straightforward. For multivariable d of xy plane, how we calculate d of xy plane? Even if I say x equal to r cos theta and y equal to r sin theta, not possible. For that we have to go by d of xy plane is same as d of xy plane by d of theta r plane into d of theta r plane. D of xy plane by d theta r plane. Consider this is xy plane and this is theta r plane. This is theta axis and this is r axis. Here this is x axis and this is y axis. In theta r plane, I have a point called r comma theta. I am sorry, theta comma r. There is a point called theta comma r. Corresponding to this, in xy plane, there is a point called x comma y. Okay, what is the actual relationship? If I draw a rectangle on theta r plane, that will map into circle in xy plane, because the way it is, x equal to r cos theta and y equal to r sin theta means in xy plane, certainly we have a circle and that is mapped to a rectangle in theta r plane. Okay, now take any point theta comma r. Similarly, that point will map to here x comma y, or x equal to r cos theta, that is a function over r and theta, y equal to r sin theta, that is a function over r and theta, x equal to g, small g, and in bracket theta comma r is a function over theta and r, x equal to g theta comma r, and y equal to h theta comma r, both are functions. Now x comma point here that correspond to theta comma r point here is nothing but g theta r comma h theta r. Now from theta comma r there is a point here. There from this point I move delta theta in along the x axis and I along the theta axis or x axis, and I put delta r, move delta r along the r axis. Now this there is a 3 point now. One point is theta comma r, one point is theta plus delta theta comma r, one point is theta comma r plus delta r. There are 3 points here. Now what we are trying to see here, dxy plane by d theta r plane. Now it talks about area, xy, two components are coming with it is area. If there is a one unit of area change in theta r plane, dy by dx, if there is one unit of change in x, then how many unit of change will happen in y? That is dy by dx. That is dy by dx. Similarly, dxy by d theta r means dxy by d theta r means if there is a one unit of area change in theta r plane, now it is area. Dy by dx means length, single dimension. It is two dimension. If there is a theta r, if there is a one unit of area change in theta r plane, how many unit of area change it brings in xy plane? Or if I have a rectangle here and here I have a circle, in rectangle if I make one unit of area change in rectangle, then how many of area change I see in circle? That is dxy plane by d theta r plane. This explanation is not available anywhere else. It is basic calculus. Dxy plane by d theta r plane or dxyz cube by d theta r phi cube. If there is one unit of volume change in d theta r phi volume space, then how many unit of volume change, that is meter cube, I see in xyz cubical region. Now anyway, let's take two dimension only. Now I have a point theta r, and from that point I move along theta plus delta theta, and from theta r I move along theta comma r plus delta r. Now there are 3 points. Similarly, there will be 3 points here. One point is g theta comma r comma h theta comma r. Now another point will be g theta plus delta theta comma r h theta plus delta theta comma r correspondingly. There is another point here, that is g theta comma r plus delta r comma h theta comma r plus delta r. If what is the area change I see because of delta theta and delta r? That area, the new area that is coming into the picture when there is delta theta and delta r is coming to the picture is delta theta into delta r. If there is a delta theta into delta r area is there, how much area I see here? If that much is the net change I see in the area, People can think in many ways. They can draw a rectangle and make delta theta, delta r change whatsoever. If there is a delta theta into delta r area change, then how much area change I see here? Here it is not a rectangle. Here delta theta into delta r are side of a rectangle. But correspondingly here there is no rectangle. But certainly we have two vectors. One vector connects g theta comma r s theta comma r to g theta plus delta theta comma r to h theta plus delta theta comma r. These are 2 points. One vector will come. Now consider 3 points are P, P1, P, P2. Similarly here P, P1, P, P2. P1 is along delta theta and P2 is along delta r. Similarly here. What is P1? What is PP1? Whatever it is. If there is a vector called PP1 and there is a vector called PP2, if these two lines came because of delta theta and delta r, if I do cross product of these two, I can see the area in between. That is the area. I am getting change in the area, new area, because we have delta theta into delta r. So now dxy plane by d theta r, now it is becomes p1 vector cross p2 vector divided by delta theta into delta r. If there is a delta theta delta r change in the theta r plane, then it will make change corresponding, it will change in the xy plane as p1 vector cross product with p2 vector. Now if that is the case, then theta I can keep this side and r I can keep that side. Then p1 vector cross p2 vector by theta r becomes p1 by delta theta cross p2 by delta r. What is pp1 vector? Pp1 vector is, I have to subtract now these 2 points. That is g theta plus delta theta comma r minus g theta comma r. Okay, this I vector plus g plus h theta plus delta theta comma r minus h theta comma r j vector divided by delta theta cross product with g theta comma r plus delta r minus g theta comma r I vector plus h theta comma r plus delta r minus h theta comma r j vector divided by delta r. If you see the first side of the cross product, then ith term and jth term. Now ith term is g del theta plus delta theta comma r minus g theta comma r by delta theta I plus h theta plus delta theta comma r minus h del h theta comma r by delta theta. Delta theta will go both places because it is plus. In that sense, the first, that is g del theta plus delta theta comma r minus g theta comma r by delta theta will become d g theta comma r by d theta. d d d of g theta comma r by d theta. It is same as g theta plus delta theta comma r minus g theta comma r by delta theta. Okay, now it becomes d of g theta comma r by delta d theta I vector plus h theta comma r by d theta. G theta comma r is x. So dx by d theta I vector plus dy by d theta j vector. Cross product with d cross product. Now there it is g r g theta comma r plus delta r minus g theta comma r I divided by delta r plus h theta comma r plus delta r minus h theta comma r by delta r j vector. That will be resolved as d g of theta comma r by d r I plus d g d h theta comma theta comma r by dr j vector. What do we get here? Now the dxy plane by d theta r plane, where we make 1 unit of change in rectangular area in theta r plane, makes how many unit of area change in a circle in xy plane grow. This is theta r plane and I have a rectangle. Corresponding to rectangle, I have on xy plane, I have a circle. If I make 1 unit of change in this rectangle, then how many unit of change I see in this circle? That is dxy plane by d theta r plane. Here I make delta theta into delta r change, not 1 unit change. That much change I did. For that I saw it is pp1 cross pp2. That much area change has come. That is pp1 cross pp2 divided by delta theta delta r. That is the net what we are going to get. That is per unit change. Anyway, what we got now, dx by d theta I plus dy by d theta j. This is one vector cross product with dx by dri plus dy by dj, dy by drj. Okay, now this is the net into d theta r plane, that is d theta dr. Okay, there is nothing division or nothing like that. So straightforward d theta dr. Like straightforward, if I say dxy, then it will become dx dy. Okay, if I go straightforward. Similarly, if d theta dr is straightforward, then it is d theta dr. Here dxy by d theta r is there, where rate of change we are seeing in area. Anyway, now we have full-fledged integration from volume 1 to volume 2. Volume 1 to volume 2. That is the integration we are doing. X square plus y square plus z square plus 3. And then dx by d theta I plus dy by d theta j cross product with dx by d theta I dx by dri plus d dy by drj. Now this is two dimension. Let's see three dimension. Three dimension, that is d of x dv by dv. What is the actual integration we are trying? Density function into dv. That is Cartesian coordinate system. That is d of x y z volume q, and then integration of volume 1 to volume 2. Density function is x square plus y square plus z square plus 3, and then d of xyz cube. D of xyz cube, I can write a d of xyz cube by d of theta r phi cube. Oh, why you took theta r phi? That is a spherical coordinate system. Boss, take anything, alpha, beta, gamma. I believe it is all right. Alpha, beta, gamma. But for sake of easiness, because I am not writing anywhere, I have taken theta r phi. But this theta r phi has nothing to do with the spherical coordinate system. These are just three variables. Why you took three variables? You cannot settle in two variables, not possible. Because it is volume now, x, y, z, volume. For volume, if I want method of substitution, I have to take three variables. So d of xyz cube is same as d of xyz cube divided by d of theta r cube into d of theta r cube. Now, if I take two cubical region, now there are two cubical region. Okay, two cubical region. One cubical region we have theta axis, and then we have r axis, and one, this is three dimension. One is phi axis. This is 3D. Here we have x axis, y axis, and z axis. Now there is a point called theta r phi, and there I grow in three directions, that is delta theta, delta r, delta phi. Now there is a change in the cubical, that is delta theta into delta phi, delta r into delta phi. For this change, how much change I see in the cubical region of xyz? Dxyz cube by d theta r phi cube. Now it will go how we can find cubical change. Anyway, if I see theta and r, then it is 2D, and then phi is perpendicular to it, 3D. How we represent 3D? Anyway, the new volume, the change in the delta volume that we are seeing in delta theta into delta r into delta phi, they are perpendicular to each other. This cubical change will not correspond to cubical change here. It will be something else. The way rectangle did not correspond to rectangle in x, y, z, it will correspond to something else. What is something else? Depends upon what relationship we are keeping. Now consider x equal to r sine phi cos theta. I can take anything. It's a method of substitution. Y equal to r sine phi sine theta, and z equal to r cos phi. This is out of the way I have taken. Okay, if that is the case, then formula of sphere is x square plus y square plus z equal to r square. If you do x equal to r, that's why it is taken x equal to r sine theta, x equal to r sine phi cos theta, y equal to r sine phi sine theta, and z equal to r cos phi. X square plus y square plus z square, if someone settle down, then it becomes r square sine square phi plus r square cos square phi r square 1. So it is all right. It respects, it is conforming the spherical algebraic equation. So it is all right. Now we have now we have cubical shape in theta or phi plane. Then we have something in the xyz as per the relationship. Now consider x equal to g theta or phi, y equal to h theta or phi, z equal to alpha, theta or phi. These are the three functions that we are seeing. Now, if I see any point here, x comma y. Now, how 3D? If I have a vector, if in I have a point here, consider I have a point here corresponding to this point. There are now I am in theta or plane. Actually, we are making there is a point called theta r phi, and along the theta axis I am moving, and new point is theta plus delta theta r comma phi. Here it is theta comma r plus delta r comma phi. Here it is theta comma r comma phi plus delta phi. This is what it is. Similarly, here it will be x, y, z, and then we move. Now there are 4 points. One point is P, one point is P1, one point is P2, and one point is P3. Now, if I talk about the volume, then can I take three cross product? If I take cross product of P, P1, P, P2, then it will give me a surface area. But the direction of the surface area will be along the z axis. If I do cross product of z axis with the new P, P3, it will not, you will not get anything. Cross product of same direction, it will not result in anything. This is called triple scalar product. This term is called triple scalar product. How area is represented? Area is represented by doing cross product of two vectors. You get the area vector. But if you want volume, then you cannot do A cross B cross C. Not possible. A cross B dot product with the C, because A cross B will go in direction of C vector or K vector. I cross J. I cross J is K. Cross K will not work. So I cross J dot product with the K, that will give the volume, and there won't be any vector. Anyway, this is how it is. So we have P P1 cross P P2, whatever comes, dot product with P P3 will give the net volume. So now we have dxyz cube by d theta r phi cube into d theta r phi cube. This d of xyz cube by d theta r phi cube will become P1 vector cross P2 vector, where P is G theta r phi, comma H theta r phi, comma alpha theta r phi. Okay, P1 is G theta plus delta theta, comma r comma phi, H theta plus delta theta, comma r comma phi, comma alpha theta plus delta theta, comma r comma phi. That is P1 P1. Okay, now if that is the case, then P1, this is P1. Now if I go P2, then that the P2 is G theta comma r plus delta r comma phi, H theta comma r plus delta r comma phi, alpha theta comma r plus delta r comma phi. That is P2. P3 in z direction, that is G theta comma r comma phi plus delta phi, comma H theta comma r comma phi plus delta phi, comma alpha theta comma r comma phi plus delta phi. This is how it is. Now d of xyz cube divided by d of theta r cube will result into what is the volume in theta r cube, that is delta theta comma delta r comma delta phi, where the numerator is pp1 cross pp2 dot product with pp3. Okay, this is how it is. Now pp1 cross pp2 dot now denominator is delta theta delta r delta phi. Since cross product and dot product are product only, they are not addition. So delta theta delta r delta phi I can keep in three places. Now it becomes pp1 pp1 vector pp1 vector divided by delta theta cross pp2 vector divided by delta r dot product in braces, then dot product of pp3 vector divided by delta phi. Now pp1 vector in similar fashion the way we did there, now it will become like pp1 vector. Now it is g theta plus delta theta comma r comma phi minus g theta comma r comma phi I plus g plus h theta plus delta theta comma r comma phi minus h theta comma r comma phi j plus g theta plus alpha theta comma r theta plus delta theta comma r comma phi minus alpha theta comma r comma phi k divided by delta theta. Okay, the I term, J term and K term. I term is G theta plus delta theta comma r comma phi minus G theta comma r comma phi I by delta theta. It will become d G theta comma r comma phi by d theta I plus H theta comma r comma phi by d by d theta J plus alpha d al, alpha d alpha I'm sorry d alpha theta comma r comma phi by d theta k. Okay, now g theta comma r comma phi nothing but x, so it will come as dx by d theta I plus dy by dj dy by d theta j plus dz by d theta k. Cross product with dx by dri plus dy by drj plus dz by drk bracket dot product with dx by d phi I plus dy by d phi j plus dz by dz by d phi k. This will come whole, then multiply out together by d theta r cube, that is d theta dr d phi. Okay, now can someone solve it? And integrand in x square plus y square plus z square plus 3. Now can someone solve it? That is dp xi plus yj plus zk is dp only. So dp by d theta cross dp by dr bracket close dot dp by d phi. Can someone calculate it? We will do it. I am not running away. So we will try it now. Now if we see dp by d theta, p is xi plus yj plus zk. Now x is r sine phi cos theta, y is r sine phi sine theta, z is r cos phi. This is what we have taken by d phi. Now it becomes r by d theta. It becomes r sine phi minus sine theta I plus r sine phi cos theta j plus nothing, 0. Cross product with sine phi cos theta I by dr. By dr we are doing, right? So sine phi r is gone everywhere. Sine phi cos theta I plus sine phi sine theta j plus cos phi k. Now do the cross product of these two. What these two? One is r sine phi minus sine theta I plus r sine phi cos theta j. Cross product with sine phi cos theta I plus sine phi sine theta j plus cos phi k. Now let's get the I component first. So I component will be j here j cross k will give me minus I. J cross k will give me I, not minus I. I. J cross A, K will give I. Here J component is R sine phi cos theta. That is J component. And their K component is R K component cos phi. So it becomes sine phi cos theta. That is I. So sine phi cos theta I vector. Similarly, if someone try to get J component, then I and K will give minus J, and anyway minus is there. It becomes R sine phi, and here sine theta. So R sine phi sine theta J. So we have R sine phi cos theta I plus R sine phi sine theta J. What is K component? There are two K components. One is this side I and J. If I do multiplication cross product, I get K, and J and I, again I get the K. What is I and J cross product? Here it is R sine phi sine theta minus I and J cross product will give K. R sine phi sine theta minus, and there it is R sine phi, R is not there, sine phi sine theta. So it becomes R sine square phi sine square theta. Similarly, this J and this J and this I will give K component again. So here it is cos theta, and here also it is cos theta, sine phi. It becomes R square sine square phi cos square theta. Now it becomes K component become R square sine square phi cos square theta plus R square, sorry, there is no R square, R sine square phi cos square theta plus R sine square phi sine square theta. If someone settle it down, it becomes R sine square phi. K component. Now we have all together this cross product is R sine phi cos theta I plus R sine phi sine theta J plus R sine square phi K. Now whole dot product with dp by d phi, where p is xi plus yj plus zk by d phi, it becomes R cos phi cos theta I plus R cos phi sine theta J plus R minus sine phi K. Now if someone does the dot product of these two, then it becomes like the cos theta, sine phi cos phi. Now it becomes R square sine phi cos square theta plus R sine R. Now here, I'm sorry, here sine phi cos phi, and there again R sine phi cos square phi sine square theta. Okay, if I do dot product, I, j, k gone. So one is R square sine phi cos square theta plus R sine phi cos square phi sine square theta plus now the last component we have to do dot product. Last component, if we remember, the last component is R. This side the last component is, I really forgot, the K component. If we take then this side I and J. So I was I believe it was sine square phi. This is what I remember. So R sine square phi was the K component. So I is R sine square phi, and there minus, and there minus R sine phi minus R to R square sine to the power 3 phi. All together it becomes R square square phi cos square theta, R square sine phi cos square theta plus R square sine phi cos square theta plus R square sine to the power sine 3 phi, sine to the power 3 phi. That's it. Okay, if someone settle down the first two, cos square theta plus sine square theta gone, it becomes R sine phi cos square phi plus, sorry, R square sine to the power 3 phi. Now someone can take R square sine phi altogether. Then it comes in bracket cos square phi plus sin square phi. Net is r square sine phi. Same thing we are getting. R square sine phi we got in a spherical coordinate system. The d volume that we had taken, that was indeed it was dr, that it was dr into r sine phi d theta into r d phi. That was r square sine phi dr d phi d theta. It also became r square sine phi, and then we have d theta r phi plane. Then it is d phi dr d d d theta dr d phi sine r square sine square phi. Anyway, we will proceed on this, but I believe, or we can just solve it. Then x square plus y square plus z square plus 3. Now it becomes r square plus 3, and then r square sine phi dr d phi d theta. Then it becomes r to the power 4 plus 3r to 3 3r square sine phi dr d phi d. If I settle down sine phi first, then it becomes minus cos phi. 0 to pi, it becomes 2. 2 I can keep outside. If you settle down d theta, then theta 0 to 2 pi, then it becomes 2 pi. Now 4 pi I can keep outside, 4 pi. And now integration of r to the power 4 plus 3 into r to the power r square, that become r to the power 5 by 5 plus r to the power 3, and r is 0 to a. 0 to a, 0 is gone, a, then it is a to the power 5 by 5 plus a to the power 3, and then 4 pi. So that is the volume. Okay, limit is volume 1 to volume 2, and it has three components, r, theta, and phi. Okay, so they are in method of substitution, r, theta, and phi what we have taken. We cannot continue as r equal to 0 to a. That we did here. If we are taking a spherical coordinate system, then I can say r is 0 to a, phi is 0 to pi, and theta is 0 to 2 pi. But here we cannot do like that, because we have done method of substitution. We don't know anything about a spherical coordinate system. Okay, we'll proceed on this. I'm really sweating. So we'll proceed on this now. Anyway, we have done the integration. Integration is r to the power 4 plus 3r square dr d theta d phi. D theta is theta, d phi, I'm sorry, sine phi is minus cos phi. So net result is theta into minus cos phi, and then into r to the power 5 by 5 plus r to the power 3. This is the net integration. Limit is volume 1 to volume 2, that we will see. So how we will break the limit as far as Jacobian and method of substitution is concerned, that we will see. Mind blowing. This is really mind blowing. This is far better than a spherical coordinate system, because with this approach we can proceed in 4 dimension, 5 dimensions, 6 dimensions, 7 dimensions. Only thing, we should know the concept of vector, so that change in volume brings how much change in volume at this side, where this side is cubical, but this side we are not knowing. Multi-dimension, more than 3 dimensions, that also can be solved through vector notation. So we will settle the limit, and then we will see. Mind blowing. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.